Okay, just showing that v squared equals n squared a squared minus x squared for simple harmonic motion. So for simple harmonic motion, x double dot is minus n squared x. That's when the centre is at 0. So if I want to get a v squared, I need to replace the acceleration with d over dx over half v squared equals minus n squared x. So now when I integrate, that is in terms of x, and this is in terms of x, I would straight out integrate with respect to x and get a half v squared minus n squared x2 on 2 plus c. Okay, now, initially for simple harmonic motion, we know that, not initially, but we know that basically when you're at the endpoints, when something is in simple harmonic motion, regardless if it is the cos curve or the sine curve, when v equals 0, we know that it is at its endpoint, so x will equal a. So if we now take that and we put in x is a when v is equal to 0, because that's at the endpoints, because there's stat points there at the endpoints, equals minus n squared a squared on 2 plus c. Then 0 is minus n squared a squared on 2 plus c. And when I move that over to the other side, c is equal to n squared a squared on 2. So what that means is that the half v squared will equal minus n squared x on 2 plus n squared a squared on 2. So if you times everything by 2, you get v squared is minus n squared x squared, I'll left that square off there, plus n squared a squared. And then if you take the n squared out, you get minus x squared plus a squared. And then rewrite it and write it in the right form, or the same form as what we're trying to prove. You swap that around, so that's a squared minus x squared. And if you look at that, that is basically what we're trying to derive. Now, on top of that, if you shifted that to the right, so you've got v squared equals n squared a squared minus x squared. Now, if you wanted to shift to the right by c, then the effect will be on the x. So if you want to do a shift horizontally, that would be x minus c squared. So that is the velocity formula when the centre is at x equals c. This one's when the centre is at 0.